There's another way we can take a look at these partial pressures. By the way, this kind of the total pressure is the sum of its part. It's known as Dalton's law of partial pressures. Not really that important, but anyways, there it is. We can take a look at the mole fraction of something. So the mole fraction, as kind of, obvious, it's a fraction. So it gets the big symbol X. So X of A, where A is whatever component you're looking at. And since it's a mole fraction, it's just going to be the moles of A over the total number of moles, right? So it's just another unit that we can use for concentration or composition. And we can say that the pressure of any component is equal to its mole fraction times the total pressure, which makes sense, right? If half of your moles are coming from one gas, then its pressure is going to be equal to half of the total pressure. So a container has 1.00 moles of H2, 2.00 moles N2, and 3.00 moles of helium. If the total pressure is 2.60 atmospheres, what is the partial pressure of helium? And so we can use our equation right above, right? The partial pressure of helium is going to be equal to the mole fraction of helium times the total pressure. And so we can plug in this total pressure of 2.6 atmospheres right into there. But then we have to solve for our partial pressure of helium, or my bad, our mole fraction of helium. We know the mole fraction of helium is going to be equal to the moles of helium over the total moles. We're told, let's see, we have 3 moles of helium. And then for our total moles, we simply sum the rest of it, right? So we've got our 1.00 moles of hydrogen, our 2.00 moles of nitrogen. And then you also have to add in helium, right? It's still a part of the mixture. It's still part of the total. So don't forget about that. That's probably the most common mistake. And then we get that the mole fraction of helium is equal to a half, 0.0500, or 0.500. Note that mole fractions, it's moles over moles, so the units cancel one another out, and it's unitless. So then we just take this value right here, plug it back into our equation, and we get 0.500 times 2.6 atmospheres. And the partial pressure of helium is 1.30 atmospheres.